probably not the only one who's got a panicked text from a loved one telling them to look outside. It's the Northern Lights. It feels like this is a phenomenon that's becoming more common, but is that actually true? On this episode of the Oxford Sparks Big Questions podcast, we're asking, why are we seeing more Northern Lights? Hello, I'm Emily Elias, and this is the show where we seek out the brightest minds at the University of Oxford, and we ask them the big questions. And I was a bit sick at the time of this recording, but still very interesting. We found a researcher who is not mad at the fact that the sun is setting at 3 p.m.
My name is Dr. Carly Howitt. I'm a physicist at the University of Oxford, and my main research interest is exploring the outer solar system.
But you've decided to slum it today with the Northern Lights for us.
Well, I've been really excited because I finally got to see them this year, like a lot of people did. So it's a personal pet project.
Is it just like anecdotally, like we are seeing more Northern Lights, or is there actual data to back up that there are more Northern Lights happening for us to observe?
There are actually more Northern Lights happening for us to observe. So the sun has a cycle. It has an 11-year activity cycle. And we are coming in to the peak activity for the next year. So through 2024 to 2026. So sort of got another year or so ahead of us. The sun is more active. It's sending out more solar wind for it to cause the lights in the first place. So it's both anecdotal because people are seeing it, but it's actually based on the science behind the sun.
Do we know why the sun is in this sort of cycle of doing this?
We don't really understand the sun's magnetosphere very well. So we know that it goes through this time where it gets really intense and its magnetic field gets really twisted and very complicated. Then all of a sudden it kind of goes nope, and everything reconnects, that the poles flip. So you could think of a bar magnet sort of flipping its north and southern pole. And then when that flip happens, which is what's happening right now, the sun goes a bit berserk. We have lots and lots of activity. We get our bonus Northern Lights. And then it sort of reconnects and everything settles back down again. And we don't understand the details, but we've been able to witness the sun doing this for many, many cycles. In actual fact, we're on solar cycle 25, I think, right now. So we've seen the sun do this a lot. We understand that it happens, but understanding exactly why, we're still trying to unpick.
Is it like we can predict when these things are happening, like with a weather report or something? Like, because I feel like when I get notice that there are like a big wave of Northern Lights, it's very like last minute text message from my husband being like, go outside and look right now. And I'm like, oh my God, what am I going to see?
Well, it is predictable. It's both things. It's predictable, but it's also hard to predict, right? Because these solar wind, the sun is enormous, and you have to have a stream of particles exactly hitting the Earth for it to cause Northern Lights on the Earth. So we sometimes know that there's an activity region that's coming in. We've had one of these, either there's a hole that's going to be coming towards the Earth, which allows more particles to stream out the sun, or there's this thing called a coronal mass ejection, which is a big event, but it has to happen exactly at the Earth. And then when it happens, the particles are streaming out at a really, really, really fast rate, like millions of miles an hour. So the sun's a long way away, but the things are traveling incredibly quickly. So we don't have a lot of time to really understand exactly where they're going to hit. So I think there's some really great apps though. Aurora Watch is a big one, and that'll ping your phone and say, hey, there's something happening, you should go outside and have a look. And so it's complicated, but it can be done, and there are some really great apps to monitor it so you don't miss any more.
Is there anything bad happening? Like this isn't like a weird omen of like that I should be afraid of, that all of a sudden we're having more solar activity. It's just a thing?
It's just a thing that's happened, and it's a thing that's happened, every 11 years since the sun started doing this. So no is the quick answer. There's nothing to be worried about. We do have to be careful with electronics in the satellites particularly. So not so much on the Earth, but you might find that some communication satellites have to switch off or do have some issues. Typically, that's all done on board. They know one's going to hit. They just might switch it off while they pass through that particularly active region for a bit and then switch back on again. So unless you happen to be a satellite or perhaps an astronaut in the International Space Station, you're just fine. It's all good.
So if I'm relying on my satellite phone and my satellite TV, I might have a bit of trouble, but my regular life should not be too disrupted by these events.
Absolutely. Feel free to go outside and look. Nothing bad's going to happen.
Is there like a specific area that I can go to get like the best view?
So yes, of course. So what happens is you have particles from the sun. So the whole process why we get them in the first place is worth understanding in order to know where to go to look for them. So the particles come from the sun. They're traveling incredibly quickly. They hit the Earth's atmosphere, and the Earth has this shield that's its magnetic field. And these particles have an electric field, and they follow the Earth's magnetic field, which funnels them into the poles, right? So the first thing you've got to know is that they're going to get funneled into the North or the South Pole. So the closer you are to the pole, the more the chance you have to see them. So that's the first instance. And then what happens is they get into the Earth's atmosphere, they excite the molecules in Earth's atmosphere, and those excited molecules, when they fall back down to their original state, they emit light. So the closer you are to the poles, the more likely you are to see this light show. And of course, it has to be dark. So it is a process that can look absolutely amazing, but it is a faint one for those people, certainly in the UK, they've gone out to look. The further you are from street lights, the better, because it's difficult to see even in the cities. So getting somewhere dark, getting further north is going to help you.
And I feel like sometimes when I take a picture of it, like with my phone looks better than my naked eye. Like, why is that?
So there's two things going on. The first thing is your phone does something your eyes doesn't do, which is it can integrate over many seconds. So it can take images, maybe 100 images over a second or 3 seconds, and then stack those all together, add them all up. And so you get things that appear very weak to your eye, that those sources get magnified, right? Because you're just able to take all of that data and make it into one bright image. The other thing is your eyes have a response. We are more sensitive to green light, right? That's just the way our eyes work. And there's lots of good evolutionary reasons why that's the case. Understanding whether there was something moving in the green grass, whether that grass was changing color was good for us, evolutionary speaking, right? It stopped us from getting eaten. But it means that we're less insensitive to the red, right? So, and lots of the emission happens at red wavelengths. So your phone doesn't have any of that. It doesn't worry about grass. Right? It can see into the red just fine. So it can see things literally your eyes cannot see. So there's two things going on. The way that the phone can process the data makes it really good at observing the aurora, but also the fact that it can see so almost uniformly across the wavelengths gives it an advantage over your eyes as well.
And the two different colors that you referenced there, do they mean different things?
They do. So as we talked about before, this idea was that, the reason we get aurora in the first place is because there's molecules in the atmosphere that absorb the energy coming from these solar particles. And then when they can re-emit those, and it's a fingerprint, the color, the amount of energy that a molecule can absorb is really specific to that molecule. So the green and the red that we see most often, so the green is, if you happen to be very close to the poles, the green one you'll probably see the most often, but it occurs quite low down in the atmosphere, and that's due to oxygen. The red is also due to oxygen, but now it's further up. So actually, if you're in the UK or further away from the poles elsewhere, you might be more likely to see the red just because it's occurring higher up. So it can be seen at lower latitudes. Literally just you can see it further away from the poles. But the blues and the purples is where you start to really get this sort of cool rainbow effect. And those are a lot less common, and they come from nitrogen. And you do have to be quite close to the place where the aurora is happening to see those. Those occur at low altitudes. And then, of course, these things can all happen together, right? So the green and the red colors can mix, the blue and the purple can mix, and you can end up with sort of yellows and pinks. And if you have a little bit of neon, which is quite rare in the atmosphere but does exist, you might get some oranges. So you can end up with all sorts of colors being seen depending on exactly the composition of the atmosphere above you.
So when you finally got to see your northern lights, what colors did you get to see?
They were red. So I'm based just outside of Oxford, and we're, at reasonably high latitudes, but of course not anywhere like, Iceland or something like that. So it was the high oxygen emissions that I was able to see. And my phone, like you said, did a much better job than my eyes, but I did get to see them.
How did you feel?
Oh, I was so excited. I did the opposite. I ran in and said to my husband, "You're going to come outside and see this." And we have young kids who are all asleep, and I was trying to persuade him we should wake them up, but he thought that was a bad idea. But anyway, we were all outside taking photos and then texting everyone and, doing all the things that you do. But I was really excited because it's something that I think you see, and it always looks amazing. The images always look amazing, but to be able to witness it with your eyes, to take the photos and see just like how that difference is, I think was just a really special thing. And to do it without having to travel far, to be able to do it in your back garden, I think was just such an amazing experience. I really enjoyed that.
I mean, okay, so you must now have some top tips for people who are looking to take the perfect photo of the Aurora Borealis. Like, what should I be doing in my iPhone/Android? We're not discriminating. Android people are people too. What should I be doing in my phone to make sure I get the best picture?
So the first thing, if you can, is to travel somewhere where there's more dark skies, right? So there's less background light. So that could be as simple as going into the countryside. If you have a large park near you and you feel like it's a safe thing to do, to go into that space. So get away from background light is the first. The second is just understand your phone, right? There's lots of ways to increase exposure times on the phone. I was using my phone's an iPhone. You're able to extend the exposure time out to about 10 seconds. That's a really great way of getting the best signal. The other thing to note is that you don't have to be holding your phone. So one thing I found worked really well for me was to set a timer, like you would if you were trying to take a photo and then sort of run around and be in it. But then just leave it on the table pointing upwards, right? So like a 3-second countdown timer to a 10-second exposure means that you don't have the jitter that comes with just holding something and you naturally wobbling it. So that for me worked really well. But there's lots of great websites actually to describe exactly how to do this and to take you through it step by step for different phones. So it's worth being prepared and knowing how to use your phone to do this as well.
So is there gonna be way more chances and opportunities in the future then to like see this beautiful phenomenon?
Yeah, so if you haven't been lucky enough to experience it yet, I know some of my family were clouded out. Like if it's a thick cloud, it doesn't matter if there's aurora if you can't see through the cloud. So not everyone for sure has got to see it yet. But keeping an eye on websites like Aurora Watch or signing up for something that's going to ping you so you know when it's going to happen is definitely a good thing to do, because the sun is really coming into its maximum through 2025 into 2026. There's going to be more opportunities to see aurora further away from the poles than is normal. So you haven't missed out. There's definitely going to be opportunities coming up.
Oh my God, I'm so excited for the future.
Yeah, I think it's really cool, and I'm excited to try and see a little bit more colours. The one I got to see was the sort of second round that hit the UK, and it was very red, whereas some people got to see green ones earlier in the first big encounter. So I'd be excited to see some other colours too. So yeah, lots of cool stuff.
And hopefully you can wake up your kids this time.
I know, right? I think he was more convinced when he saw the photos, because if you go outside sometimes you're like, is it pink? Is it not? And then you take the picture and it's like, oh, that's some aurora. But it wasn't. I think if it was dancing across the sky, the way you see it sort of in really high latitudes, we'd be waking them up. But it's always a tough call, right? And they're so little, they probably wouldn't remember it anyway and just be grumpy the next day. So yeah.
Being a parent is so hard.
Yeah.
This podcast was brought to you by Oxford Sparks from the University of Oxford, with music by John Lyons and a special thanks to Carly Howitt. Tell us what you think about this podcast. We are on the internet at Oxford Sparks. We also have our wonderful website, oxfordsparks.ox.ac.uk. You can get in touch with us there. I'm Emily Elias. Bye for now.